Hello, everyone. My name is Michaela Mitchell, and this is Group 8 for our project for the Supermarket Distribution Center simulation for the Semio competition of 2019. This presentation we will walk through model assumptions, modeling approach, input analysis, the model itself in Semio, and then an ending conclusion. For our model assumptions, for this project, we are simulating the unloading trucks into a warehouse and moving pallets to the shelves, only considering the aisles each pallet should go. At the warehouse, there are three primary operations: put away, select, and replenish. The put away operation includes receivers who unload delivery trucks and put away operators who transport the pallets from the receiving area and place them on racks. For the select operation, selectors handle outbound shipments and pull products from the rack to ship. Finally, for the replenish operation, replenish operators take pallets stored on higher shelves to replenish the stock the selectors picked for order. In the simulation, there are two shifts for the operators. It's 7 to 1500 military time. And then the second shift is from 15-hour military time to 23 military time. For our modeling approach, we have objects, which were load pallets on the forklift, time to lift or lower to rack location, time to put a pallet on rack, unload pallet from forklift, RPJ speed, high reach forklift speed. For our elements, we had the 4 operators per shift, 32 high reach forklifts, and 2 robotic pallet jacks. For our entities, we had 12 replenish operators per shift and 2 receivers per shift. Now we're going to move on to our analysis. First, we analyze the number of shipments by the time of day, where we observe the 3 busiest time of day will be between the times of 6.66 to 7.15, 9.11 to 9.6, and 11.57 to 12.06, where the number of shipment racks between 20 and 25. Second, we analyze the shipments received per day of week, and we notice that the 3 busiest days would be Thursday, Friday, and Saturday, with number ranking between 40 and 50 shipments. Here are 2 other graphs that shows the number of shipments each day and the shipments by time of day. Now we're going to move on to the Semio video with Luis.
Hello, I'm Luis Gonzalez with group number 8, and today I'm going to be talking about the warehouse simulation we did for our final project. So first of all, I'm going to talk about the different type of entities we got. We got shipments, we got pallets that are within the shipments, we have receivers, which are unloading the trucks, and then we have put away operators and forklifts that are distributing our pallets, within the warehouse. Here in the source, we have the entity type of shipment being generated, and they're arriving following the arrival rate table of shipments. This shipment rate table was created based on our historic data, and what we did was just figure out the amount or the average amount of shipments per hour per day for a full week of shipments arriving in the facility. Then we went ahead and in the output node of this source, we decided to add an add-on process trigger, which is an assign. We did a model the entity number of pallets. This is a state, that was assigned to each entity. And basically what this helps us do, also we assign the out number, but the number of pallets is just saying how many shipments or how many pallets we have inside that shipment. So that distribution is following a random that continues, and it starts at 1, so only 1 pallet per shipment, all the way to 121. So it varies a lot, and we were able to figure this out from the historic data. Then we go into facility. Um, we get here into our security gate, and here we have a transfer node. The transfer node is following a selection goal of cyclic, so it goes or it starts at one node and then it continues to the other one, and then it goes consequently by there. We have the logic of it selecting from a list of nodes, and these nodes are referencing all the nodes that we have in our separators. The nodes are the inputs of each dock. So we did 1, 2, 3, 4, and it goes all the way. So we see in our model when we start running it that the shipments are first here, then they arrive here, then they arrive here. So that way we avoid clogging of the system of the docks, and we also have like a regular or a better distribute utilization of our docks. After that, we get into the separators and holding docks. So into the separator, there is something pretty interesting going on. We use the separation logic of make copies. So the shipment will arrive here, and then it makes a copy. And how many copies it makes is based on the number of pallets. Remember that other property that we show, which is the number of pallets. And so now each one has a number of pallets assigned to it, and it creates a new entity called pallets, and that is pretty cool. So we will see it. I actually want to run it here because I want to see how it changes from a truck arriving in the facility into pallets arriving in the facility. So I'm going to click here, going to fast forward till the moment. Oh, okay, I missed it, but that's right. We can see the pallets are already here. And if we do this, we can see them being distributed by the forklifts into everywhere. But for the moment, we're just gonna focus into another truck coming into the facility. So we saw it here, we saw it arrive here. We should see another one soon. Into dock number 14. And pretty much we have our operators right now distributing everything around. This one's taking a little bit longer than usual. Ah, here it comes. There we go. So, and then our operator, it will process this whole thing based on the processing time given in the model, not in the model, in the instructions, and it's a random dot triangular. We'll see it here in our process logic, processing time random dot triangular, and it's processing the number of pallets. So that was another neat trick that we learned. We had to reference that state, so we were able to process the right amount of entities and not only process the shipments. Then after that, it pretty much we claim the workers. Um, we claim the workers here at the separator to be working inside here and unload pretty much all the pallets into this holding dock. This is the name that we give to this. So all this path were created or were united into a single network called receiving operations. So we go into definitions, elements. We have receiving ops as a network. Here we we allow our dock workers to move from one dock to the other without any problem, and it's really helpful. Our pallets, once they are unloaded from the truck, they wait here, so they write on transports as true. They're selecting from a list, and the list is the aisle transporters. So on that inside that list, we have the put away operator, and we got the forklift. Once the shipments are here, the forklift and all the workers pretty much are following the same work schedule. They will come in here and they will pick it up, and based on the aisle number, they will then distribute everything around our warehouse. So how do we assign the aisle number? Let's find that out real quick. So we went into processes for the holding dock. So holding dock, add on processes. We created another process called model entity.aisle number, which is assigning the aisle number state. It's assigning it in a number. This distribution was based also on the historic data, and pretty much the reason why we're using 1, 2, 3, 4 is because our data or sorry, our list of nodes of our transporters. I'm so sorry, where is it? There we go. On tables, this table of aisles, it follows 1, 2, 3, 4, 5, 6. That's the reason that we had to use those number and we didn't use the number for the aisle that we see on the layout, which is, we can see here 79 goes with 30. Also, here they're writing on the transport, they're waiting on it, so let's see how that actually looks. Let's run our model once again. Let's fast forward it to the first arrival, which is at 8:40 a.m. Okay, so here we want to see how everything is working. So we got our operators. Oops, that's too fast. We got our operators picking it up, and this worker that came back is actually a bug that we saw from the system that is coming from aisle number 34. This node right here is the only one that is giving us a problem, and it's because when we created the network with all these paths up here, sorry, all these paths up here, there's part of the same network, so these workers are only allowed to move them in that network. It it is given an error saying that it doesn't have a way to get back. I pretty much deleted and changed everything a couple of times and redid the network, and that aisle for some reason is not catching up with everything else. But the rest of the aisles are working perfectly, and we can see our workers coming in and putting everything away, nice and tidy. So if we fast forward this, we will see that they keep busy, that we got more shipments arriving. Now it arrives into dock 12, then into dock 13, so it's cyclical. They're still unloading stuff from the first one though, or putting away stuff from the first one. So they finish, now they go into the second one and they distribute it, and they work pretty efficiently. This path actually has over 300 links and it worked really, really nice. Um, if we fast forward this all the way till the end, I want to show how our results are looking and how we're validating our data. We have over 800 shipments and 27,000 pallets of products that are being generated, and that goes well with our data. So now that it's almost done, we will go into results. Just one more second. We go into results, and we can see, yeah, we got 26,564 pallets created, and we had 805 shipments generated. Well, they were actually created 823, but only 805 were destroyed. Also, one thing that we thought it was pretty cool was we decided to go the extra mile and we imported these racks. So we found an AutoCAD file, we imported it into Simio, and it looks just a little bit cleaner, looks better. Oops, too far. We also had this gate here at the beginning just to, try to model the facility itself, but it was pretty cool to learn and do all this stuff. Our model runs well for the full period of time, and the model validates, so hope you like it. Thank you.
Okay, so now we're going to go and move on to our conclusion. Our conclusion just consists of some analysis that we did with PDFs, CDFs, and QQ plots. The first one we did was the input analysis for the aisles used. For our conclusion for this output data, we recommended to make use of the gamma distribution with the data that was provided. Since looking at the PDF and the CDF would have the best fit for our model. Due to the p-value being greater than the null hypothesis, we are unable to reject the initial hypothesis. We also made use of the product data, where we recommend to make use of the Weibull distribution. In the graph showed are the best fit PDF and CDF for the product column of the data collected. This data showed that the probability over an inter-arrival time in seconds. Over the course of time, the p-value increases to a peak and then decreases back towards 0. Due to the p-value being less than the null hypothesis of 1, we are able to reject the null hypothesis. And finally, we concluded that our RAC data that we recommend that the use of the stable distribution. The independent variable is the case, in this case, would be the RAC data that was selected. This data shows that the probability over an inner arrival time, where the p-value increases to a peak and decreases back to zero, and it looks almost symmetrical if you see in this graph right here. And due to the p-value being less than the null hypothesis of 1, we are able to reject the null hypothesis. I hope you enjoyed our video and thank you for watching.